the highest common factor of 28 and 32. The very first method is prime factorization, as we have discussed. So let us prime factorize 28 and 32. In 28, the highest power of 2 is a square, that is 4, because it is not divisible by 8, which is 2 cube, but it is divisible by 4, which is 2 square. So 4 into 7 is what we have here. And 32 is anyhow 2 power 5. So when you try to find out the HCF of these two numbers, take the least power of the common factor. Now the factor needs to be common. In case of LCM, we considered each and every prime factor, even if it has power 1. But here, even if it has power 1 in the factorization of one of the numbers, and it may not be present as a factor of another number. But in case of HCF, we will consider only those factors which are factors of both the numbers. So here 2 is a factor of both the numbers, but 7 is a factor of 28, but not of 32. So 7 is not to be considered. Now take the least power of 2. Here we have power of 2. Here we have 2 raised to power 2, and here we have 2 raised to power 5. Least of these two is 2 square, which is equal to 4. So 4 is that highest number which will divide both 28 and 32, so as to say 4 is the HCF of 28 and 32. We can use another method which is called the continuous division method. In this, we will divide the greater number by the lesser number. So 28 and 32 goes by 1, you get 28 here. The remainder is 4. Now, the previous divisor, 28, shall get divided by this remainder, 4. 4 sevens are 28. While doing so, when you get 0 as the remainder, then the divisor in the final or the last division shall be considered as the HCF. So HCF here again works out to be 4. Now let us look at another question here, 493 and 928. Now 493 and 928, the prime factorization is going to be quite hectic. So let us make use of continuous division method. So 928 gets divided by 493, goes by 1. We get the remainder as 435. Now 493, the previous divisor, becomes the dividend and gets divided by the remainder obtained here in the previous division. So 435 divides 493, goes by 1. So by 435, we get the remainder as 58. Now again, the previous divisor becomes the dividend. So this remainder, which is 58, divides the previous divisor 435, goes by 7. We get 406. Now again, we get remainder here as 29, which shall divide the previous divisor, that is 58, goes directly by 2. So hence, the last divisor, which gets you 0 as the remainder, shall be our HCF. So HCF for both these numbers is 29. Now find out the HCF of 100, 120 and 125. Now these are such kind of numbers for which prime factorization process can be adopted. Now while doing so, 100 we know is 2 square into 5 square. 120 is 4 into 3 and again 2 into 5. So this is 4 into 3 into 2 into 5, that is 10. 4 here is 2 square. So this shall become 2 square and another 2 here, so 2 cube into this 3 into this 5. That is 8 into 3, 24. 24 into 5 is 120. 125, again quite simple. 5 cube is 125. So the HCF here will be a number which is common to the prime factorization of each of these three numbers. 2 is present here, 2 is present here, but do we have 2 here? No. 2 is not a factor of 125. So we shall not consider 2 while taking the HCF. 3 is present here. But do we have 3 here as a prime factor of 100? No. It is not a factor of 100. It is not a factor of 125 also. So 3 is also ignored. Then 5 is given as a factor for 100, 5 is a factor for 120, and 5 is a factor of 125. Least power. We have powers of 2, this is power of 1, and this is power of 3. The least power here is 5 power 1. So our answer here should be 5 power 1, that is 5. So the HCF of these 3 numbers is 5. Now we can also solve this using continuous division. Now how should we use continuous division for 3 numbers? Take any 2 numbers. One should be bigger than the other, 120 and 100. The 100 divides 120, goes by 100. Remainder is 20. So the first divisor becomes the dividend and the first remainder becomes the second divisor. The remainder is 20. Now 20 divides 100, goes by 5, and you get a 0. So whichever divisor gives you 0 at the end is the HCF. Now HCF of 100 and 120 is 20. But still the third number is left, that is 125. So what we shall do is, we will divide this third number 125 with the HCF obtained for the first 2 numbers, that is 20. So goes by 6, becomes 120, remainder is 5. So 20 now becomes the dividend here. So 5 4s are 20, you get a 0 here. So ultimately 5 happens to be the HCF. So first, through continuous division method, you take the HCF of first 2 numbers and that HCF, and then apply continuous division between the HCF obtained from the first 2 numbers and the third number. So HCF of first 2 numbers and third number. Apply continuous division method. So whichever divisor gives you 0 as a remainder shall be our HCF. So here also we get our HCF as 5. Now how do you find out the HCF of decimals? So HCF of 1.5, 0.24, 0.06, 0.036. Well, in general, the process remains the same. And that is, first, we will convert these decimals into integers. And the smallest decimal here is 0.036, which needs to be multiplied with 1000 so that we get the integer value as 36. So hence 1.5 and 0.24 also will get multiplied with 1000 to get you integer values. So the integer values obtained are 1.5 into 1000, that is 1500, 0.24 into 1000, that is 240, and 0.36 into 1000, that is 36. Now we shall take the highest common factor for these 3 numbers. And by employing prime factorization, you would be able to solve this pretty fast because 1500 has a 100 in it. So as it is, 2 square into 5 square is 100, into 3 into 5 is 15, so 15 into 100. Now this 5 and this 5 gets combined together, so 1500 can be prime factorized as 2 square into 5 cube into 3, given here. Now similarly 240. 240, quite simple, it is 8 into 3 into 10, 8 into 3 is 24 into 10. So this is 2 cube, this is 3, and 10 here is 2 into 5. So 2 power 1 and 2 cube get combined together. So 2 power 4 into 3 into 5 is what we get here, which is also written here. 36. 36, kindly remember it as 2 square into 3 square. It is 6 square and 6 is 2 into 3. So 2 square into 3 square. Now take the HCF of these 3 numbers by taking the least power of common factors. Now 2 is common to all the 3. Least power is 2 square. So we get a 2 square here. 3 is common to all the 3. Least power is 1. So 2 square into 3 power 1. 5 is not present here as a factor of 36. So hence 5 is not to be considered. So this is 4 into 3, which is 12. Now after getting 12, because we have multiplied these numbers by 1000, divide this by 1000 to get 0.012 as the HCF. Now if at all we are asked to find out the LCM and HCF of fractions, then how do we proceed? Well, we found out the LCM and HCF of integers, then we found out the LCM and HCF of decimal values. Now we will look at the concept of finding out the LCM and HCF of fractions, which is very, very simple. So LCM and HCF of fractions, if you want to find out LCM of fractions, well, a fraction is P by Q form, that is numerator by denominator. So if some fractions are given to you and you are supposed to find out the LCM of fractions, then whatever you need to find out, the same thing you will find for the numerator, and the other will go to the denominator. What is other? Well, we have only two things to find out, LCM and HCF. So if you need to find out LCM of fractions, LCM of numerators by HCF of denominators. Similarly, if you need to find out HCF of fractions, HCF of numerators. Now, whatever you need to find out for the fractions, the same thing you will find out for the numerator, and the other will go to the denominator. Now, let us have a look at a question here. Find out the LCM and HCF of 1 by 3, 2 by 9, 5 by 6, 4 by 27. So, to find out the LCM, we know it is LCM of numerators by HCF of denominators. Numerators are 1, 2, 5, 4. So 1, 2, 5, 4. Find out the LCM of these. And denominators are 3, 9, 6 and 27. You have to find out the HCF of these. So 1, 2, 5, 4. Evidently, it is 5 into 4 only that you need to consider, because 2 is a factor of 4. So 5 into 4 is 20. It will be divisible by 2 also. And HCF 3, 9, 6, 27, you see that each of these numbers is divisible by 3. And that is the highest common factor. Because 3 divides 3. You can't have a number greater than 3 as a factor of 3. And if we need to find out the HCF of fractions, so HCF of numerators by LCM of denominators. So 1, 2, 5, 4, their HCF is 1, because you have prime numbers here. And 3, 9, 6, 27, the LCM is 54, because 27 is not divisible by 6, and 6 here is an even number. So obviously, the LCM should also be an even number. So the next multiple of 27 is 54, which is divisible by 6. And as it is, 54 is divisible by 27, so hence it must be divisible by the factors of 27, that is 3 and 9 as well. So this is how we find out the LCM and HCF of fractions. Now, a very important concept based on which many times questions have been asked. LCM into HCF equals first number into second number. Now, if two numbers are given to you, then this is the relationship between those two numbers. The product of their LCM and HCF will always be equal to the product of the two numbers. Now, the numbers have to be co-primes. That is, their highest common factor should be 1. So we can say LCM. Now LCM is also equal to HCF into product of co-prime factors. Now we will definitely solve question on each of these concepts, because if the factors of two numbers are co-primes, say A and B, and their HCF is H, then the two numbers will be HA and HB. So in that case, LCM into HCF equals HCF into A into HCF into B. So these two HCF will get cancelled. Now we can say LCM equals HCF, this HCF comes here, into product of the two co-primes. Now if the HCF of two numbers is 11 and their LCM is 7700. So HCF is 11, LCM is 7700. If one of the two numbers is 275, so let us say the first number here is 275 and we are supposed to find out the second number. It says find out the other number. So LCM into HCF equals the first number into the second number. You can also name them as A into B or X into Y, whichever way you're comfortable. So LCM is given to us as 7700. HCF is given to us as 11. And first number is given to us as 275. And we have to find out the second number. Now, a careful look would suggest that 275 is divisible by 11. And how is that? Well, 2 plus 5 is 7. And here we are having a 7. So 7 minus 7 is 0. So let us balance these out. So let us cancel 11 and 275. So 11 2s are 22. 5 remains 55. So 11 5s are 25. Now 77 into 100 by 25 equals the second number. Now 7700, I have opened this and written it as 77 into 100. Reason, 25 will cancel out 100 by 4 because 25 divides, because 100 is a multiple of 25. So goes by 4. So the second number here shall be 4 7s are 28. Again, 2 is carryover. 4 7s are 28 plus 2, that is 308, which becomes the answer. This is the second number. Two numbers are in the ratio 3:4 and their HCF is 4. Now find out the LCM of the two numbers. See, if the two numbers are in the ratio of 3:4, that becomes A is to B. Why? Because 3:4, these two numbers are co-primes. So the first number X, let us say, happens to be HA. This is A, this is B. And that is 4 into 3, which is 12. And Y happens to be HB. That is 4 into 4 equals 16. So we already know that LCM equals HCF into product of co-primes. So we can simply say this is 4. HCF is given at 4. Product of co-primes, 3 and 4 are co-primes. So let us take 3 and 4 as A and B. So this is 4 into 12. That is 48. So as it is, we know, if we perform a check, that LCM of 12 and 16 is 48. 16 into 3, 12 into 4. Now the LCM of two numbers is given as 48. So LCM is 48. And the two numbers are in the ratio 2:3. 2:3 again are co-primes. So we know X is to Y. If these are the two numbers, they're in the ratio 2:3. That is HA is to HB. Find out the sum of the two numbers. We need to find out A plus B. So if we know that LCM equals HCF into product of co-primes, then HCF here equals LCM by the product of co-primes, which is A into B. So LCM is given to us as 48, and A and B here values are 2 and 3. So 48 by 6, which is nothing but 8. 6 8s are 48. So the value of HCF here is 8. Here also it is 8. A and B are 2 and 3. So the two numbers actually are 8 into 2, that is 16. And 8 into 3, that is 24. And 16 and 24 have their HCF as 8 because both these numbers are divisible by 8. So now sum of the two numbers shall be 16 plus 24, that is 40. The LCM of two numbers is 4107 and HCF is 37. So LCM is given to us as 4107, HCF is given to us as 37. Find out the greater value out of the two numbers. Now we know that LCM is equal to HCF into product of co-primes. These are co-primes. So this is 4107 equals 37 into A into B. So 4107 by 37 works out to be 37 into 1 is 37. 41 minus 37 is 4. 4 and 0 become 40. So 37 into 1 again 37. 40 minus 37, 3. 3 combines with 7 to give you 37. 37 ones are 37. So 4107 goes by 37 and gives us a value 111, which has to be equal to A into B. Now A into B is 111. Let us factorize these. 1 into 111. The other is 3 into 37. So let us take both the pairs here. When we take A is equal to 1 and B is equal to 111, in that case, first number HA and second number HB becomes 37 into 1 and 37 into 111. So this gives us 37 and 4107. Now if we take the second case here, that is A is equal to 3 and B equals 37, then we get 37 into 37, that is 1369, and 37 into 3, that is 111. Now out of these, we want a greater value out of the two numbers. So let us go for this pair when we get greater value as the LCM of the two numbers, that is 4107. So the greater value out of the two numbers will be 4107. In case 4107 is not given amongst the choices, in case the fourth choice does not say none of these, and 1369 is given to you amongst the choices, please go for that as the answer, because this happens to be the second highest out of the choices. But the actual answer here is 4107. If it is not given, then 1369. So that brings us to the end of the session for the topic LCM and HCF. Please do revise this and solve questions, practice to master the techniques and get acquainted with the variety of questions. We will meet again in the next discussion. Till then, I wish you all the best. Please work hard. Take care of yourself. Stay safe. Thank you so much.